Welcome and thank you so much for joining me today. So we are going to be looking at average rate of change. Now, when we've talked about rate of change before, it has been consistent. It's been a constant, which means we have been referring to a straight line. And how we worked out the rate of change all came down to our rise over run. So when we are thinking about average rate of change, we are looking at curves that are not consistent, meaning it's not constant. So we are going to have to use our understanding of rate of change to get the average. And it's the same process that we are going to be looking at. So to get the average, we are going to be looking at our rise over run. And how I like to think about it is I'm going to call this A and I'm going to call this point B. So that just means that point A, y is would equal the function of A. And that, so function of A will spit out the y value. And the function of my B will spit out the y value. So that's why I use function B and function A. So just like we normally do with talk about rise over run, when we are talking about the average rate of change, we are going function B, so our y2, and we are taking it away from function A, and then we are going to, that will give us the difference of our y, and likewise with our x, we are going B take away A, our B point, take away our A point will give us our run. So all we need to do now is really think about our what those points mean. So here I've got B, comma, function of B. Over here I've got A, comma, function of A. Or another way I could say function of A is y1 and function B is y2. Okay, so now I've done that, I'm just going to be looking at my values and substituting them in to find this line. Because remember, this line is the average rate of change between those 2 points. So that just means my function B is 48. My function A is 32. I'm dividing by B, which is 8, minus A, which is 3. So 48 minus 32 is 16. And 8 minus 3 is 5. So this is my average rate of change. I am able to also write it in a decimal if I would like. So it's 3 and 1/5, which is also 3.2. So that is my average rate of change between distance and time. Now, let's have a look at this equation here. So this equation is the square root of 5 minus x. And we are looking at the elements of x when x is negative, between -1 and 2. So first thing I'm going to think about is, what does this graph look like? Well, first thing I want us to think about, and there's a bit of transformation going on here. First thing I want us to look at is this graph. So I'm going to draw the graph first. So I'm going to make some space. There we go. So I'll draw it down here actually. So if I'm thinking about the basic graph, so I'll do everything in a different colour so it makes it easier for us. Red. So if I'm thinking about the basic graph of the square root of x, so the first thing I think about is that my graph is going to be going like this. The next thing that I look at is I go, well, another way I could write my graph, I'm going to do next part of the transformation over here. And I'm doing the transformation first just so you can see it, of what the graph looks like, and then I'll go over average rate of change. So then I've got x plus 5. So if I'm drawing x plus 5, all that means is, well, x would need to be -5 for y to be 0. So at -5, my graph is here. The next thing I look at is my last part, which I have the square root of -x plus 5. So that is the same when I've got, instead of when I've got -5, it will be +5. So that just means I'm going to have my graph here, and it is going this way. So I've now worked out what my graph looks like, so then I can draw and talk to you about what's going on. So we are looking at x elements when x elements is -1 and 2. So 2 will be here, and -1 will be here. It's not completely accurate in terms of my drawing. So that just means I've got 1 point here and 1 point here. So we are looking at our average rate of change between those 2 points. So we're drawing a nice line. Now when we've got a line, that means we are looking at the gradient, the slope, which is rate of change. So again, we have our rise over our run. So that just means that we are thinking about two things. We are going to give each of our points something different. So I'm going to be giving this point here, saying it's A, and then function of A. Here I'm going to say B and function of B. Trying to keep in line with that formula. So now I know that, I'm going to be thinking about, okay, well, let's have a look. First, function of B. So I know my B here is going to be 2. What is my function of B? Well, if I put 2 into this equation, let's see what happens. 2 becomes -2. -2 plus 5 becomes 3. So it becomes, take away the square root of 3. Now we're going to look at A. I have A here, which is -1. And let's look at function of A. So if I put in -1, it becomes 1. 1 plus 5 equals 6. So I've got the square root of 3 minus 6 divided by 2, take -1, so that will be divided by 3. I'm going to use my calculator. Square root of 3 minus 6 divided by 3, -1.4. -1.4. So that is my average rate of change. I really hope that helps you understand average rate of change. If you need any extra help, message me and I'll get back to you.